All right, good morning, everyone. My name is Sam Van Oort. I'm one of the CloudBees engineers. I have the pleasure of being the maintainer of the Pipeline plugin suite. And today I'm going to tell you about how you can use systems theory to solve your pipeline performance problems and optimize your DevOps flows. And if I can be perfectly candid, this is going to be much thinner on theory and much thicker on practical tips than I had planned, as well as showing off some new features and giving you guys a sneak peek of what's coming with the future of pipeline. And there's some exciting stuff coming. All right, so let's talk about why performance matters, especially in the context of DevOps. So there are several aspects to it: latency, resource use, and throughput. And for our purposes, I'm going to conflate all of those into the general performance umbrella and summarize as performance is money. Faster performance, more value delivered, less time, less engineers, less hardware. Bad performance, that's also an administrative problem for stability. In the last week, I had the dubious pleasure of working with one particular very large Fortune 500 company that was having very serious stability problems as a result of a performance issue in their masters, specifically tied to GC. I'm actually going to show you some examples from that since the GC logs are fairly anonymized. This is one of those things where I, as a member of CloudBees who has an active presence per the keynote with 43% of the Fortune 500, I get a lot of insight into what's going on with performance. I have the sometimes dubious pleasure of being the guy that gets called if no one else can solve issues, especially with pipeline. So I've seen some shit, if I can be perfectly honest. So within the Jenkins project, we believe in attacking problems head on. So this is the year we finally dealt with some of the performance headaches that have been plaguing pipelines specifically for several years. But first, let me give a little background. I'm going to refer to systems theory for some specific aspects of this. You don't need to absorb all this. The gist is basically systems theory talks about how you break down complex systems into subsystems and look at how they have patterns of interactions. And that's an interdisciplinary thing. A system could be an economy, it can be a software system, whatever you like. There's some things that hold true across all of those cases. All right, so I'm actually going to give a concrete example from pipeline. So this is actually within the guts of how pipeline runs. So this is actually the way that we handle running steps. And I'm abstracting away just tons of stuff here because the guts of the code are very complicated. People who can't see may want to move over in this direction, since we don't have two screens today. Basically, when you run steps, there's a lot of different things that they do, and one of the key things they do is persist a record that you ran a step. So these are two separate systems that interact. This is a storage system and the actual execution runtime. And they do a ton of stuff. They write a record that you've got some step that you're going to run. They write a record that this started a particular time, so you know how long it took to run. They store what the arguments were for the step, some other basic metadata that's going to depend on the step itself. And there's also stuff that can be added while you're running, so specific execution information, labels and things, all kinds of custom goodness. So when you look at this, there's going to be a couple of obvious issues from a performance standpoint, right? You've got a ton of different coupling between these two systems, a lot of different things happening. And almost all of this activity is written directly, or was written directly to disk. This is an old model. This has changed. I'll give you an example of what the feature is, and I'll tell you what's changed a few slides down. So one obvious solution is to consolidate this. You've got a whole bunch of different activities, each of which triggers a write. See if you can batch those up together. And we're doing that now. I've actually added that feature as of earlier this year. Part two is to see if we can cache some of this and then defer those write activities. And we're also doing that now too. I'll give another example of one of the system-level performance problems that we've attacked in pipeline. So the pipeline program has sort of a tight loop that runs Groovy logic in this custom CPS interpreter, which is way out of scope to go into the details of right now, but The gist is that with every method call, you're checking it against the security sandbox. Yeah, you guys know those exceptions you get. Hey, I need to approve this method. Who here loves those exceptions? Who here hates those? Okay, cool. Then I'm glad we're all in agreement there. It's terrible. One of the key problems is this is the sort of the tight main loop for running a pipeline, and that check that you're running in script security is happening with every method call, and that check is actually using an O of N scan of all of the validated signatures until it finds a match. And here's the other fun part. It has a global lock in this while it's doing that scan, or it did. So what I've changed in the last year is we've removed this global lock. We've gone to a read-write lock model so that most of the time there's no lock contention. That O of N scan is replaced by an O of 1 cached hash map lookup for almost all of your calls. This means that this particular part of the loop, the sandbox, is much faster, and there's another fix to deal with the pain point of those signatures and those approvals that I'm going to talk about later, which I think is actually pretty exciting. All right, so I'm going to give a big, ugly, nasty graph here. You don't need to absorb it. Don't worry about it. The big thing to know is, holy crap, this is ugly. An ugly graph diagramming the system interactions means that you have an ugly set of systems. This is intentionally not beautiful, because if I made it beautiful, I'd be lying. I'm gonna let it down straight for you guys. I'm not gonna kind of mince words here. I'm just gonna keep it real here. This is an ugly kind of interactions. The key thing to know is that here you've got the main loop in blue. This is like the tight loop that does all of the stuff you care about running steps. This is all the other crap that's associated with it and runs with cycles of that loop. Everything in red here is writing to disk. So there's a lot of persistence here. All right, so what can we do to fix that in this case? So first thing is we can't actually get rid of any of these systems because they do actually do something critical. And we can't actually kill those connections because they do actually need to save sometimes. Otherwise, we're violating the promises we've made with Pipeline to provide resumability. But what we can do is ask the question, do I really need to write in this one particular case every time we trigger a write? So with that, we do have to ask, what's the implications of not doing that write? What happens if we wait to do this? What happens if this write doesn't get performed, but one of the other pieces of data does get written? And that means you have to kind of do a trickling graph here to see this depends on this, depends on this, depends on this, and know in which order things need to be written. And that's important. That actually required a lot of work to ensure there's no issues there. But what we've done is decouple from that tight persistence loop in some practical cases. You can't cut out those systems, but for practical running pipelines, if you use the right settings, those interactions no longer happen except once or twice per run. And I'm going to tell you a little bit more how that works down the road and what the implications are for your performance and persistence model. And so all of this was done earlier this year as part of Project Cheetah. There's a Jenkins IO post I put up with some more extensive details. I've put a lot more work into kind of updating with bug fixes and additional optimizations since then. Important thing to know is the part that you actually see out of this is very small. Like you see just a little tiny thing in the UI, but actually what's happening under the hood is huge. Like this is tremendous amounts of changes in the actual pipeline execution engine to support this. All of the stuff that's writing to disk has to be aware of this set of features that I've added. All right, so one of the key things that I've done with Project Cheetah for Pipeline is add what I call durability settings. Basically, this is a toggle that you can pick as an admin or as a pipeline user to say, this pipeline, we need it to run faster, or this one, we really need to make sure there's no potential to lose any information about it. In any case, no matter what happens, someone yanks the power plug in your server, AWS decides to crap out for whatever reason, which does happen occasionally, as much as we'd like to admit it doesn't, or like to hope it doesn't, it does happen from time to time. You get a trade-off here, and it's actually not a bad trade-off. So the default maximum durability mode is much like how Pipeline used to run. It writes constantly to disk. It ensures that any time your master can go down suddenly with no warning, you can lose access to disk, and generally your pipeline will come back in a clean state. It may not be able to resume depending on what you were running if it's something that doesn't support that, but at least you'll still have the record of where it was, and it'll fail cleanly, and you won't lose anything. And that's important for things like production deploys, where like you want to make absolutely sure you know what state it's in no matter what happens. It doesn't matter if a meteor crashes into the network link or the data center. Well, it might not survive that, but it works pretty darn hard to try. So the middle setting, this is something that's new and kind of unusual. It's a niche use. The less durable, a bit faster setting, or survivable non-atomic, is the short string it'll give you. What this does is remove atomic writes. And that sounds like a kind of a very nitpicky thing, but actually the reason that matters is changes were made in Jenkins core a couple of years ago, some months ago, that force every atomic write to flush to disk in every case, and that means you don't get operating system caching for things, and that's much slower. For most things, you don't do that many atomic writes, and Jenkins Pipeline does a lot because of how it provides that durability. So this can be considerably faster for those cases, and the only case you risk losing the ability to resume your pipeline is if the storage is physically disconnected, or you unmount like the volume while it's running, or suddenly kill a container that's running, or there's power loss to some of the storage appliances. So that's a small trade-off. Now, what I'd like to encourage people to use in general is the performance optimized mode. This is the new sexiness. This is a lot of the reason why we did Project Cheetah. And what this does is batch together all of those writes. Like I remember I talked about how every step that runs persists a bunch of different pieces of information a bunch of times. So what this does is says, do we really need to do that continuously? Or can we wait? Let's be a little bit lazy about this. So what we're going to do is, for all of the flow nodes, the records of those steps that ran, we're just going to hold them in memory for a bit, and then at the end, we're just going to flush it out in one big file. Before this, these other modes use single files for each step. People who've done system administration or looked a lot at kind of storage performance, lots of tiny writes is a really bad pattern for performance. One big write, one big streaming write, that's much faster. You're dumping it all at once. We also don't use the atomic write mode. Now, of course, you're going to wonder, well, what about how we support the ability for pipelines to resume when you restart the master? That's actually OK. That's not a problem here, actually. And the reason is that there's a way we can listen for when Jenkins tries to shut down. And most of the operations that will manage masters will do that clean shutdown. Your service scripts, they'll shut it down. You can do the restart URL or the shutdown URL. And before it shuts down completely, it'll write all that to disk, so there's nothing lost. The only case you got to worry about is if you don't do that. So for example, you kill the running Docker container. Someone p-kills the process. The operating system or the system itself has a failure. Like ohmkiller in Linux will shut down a process if your actual host operating system is running out of memory. And that means you don't get a chance to do anything. You don't pass go, don't collect $200, you're done. Process dead. So this is not ideal if you think your master is going to fail repeatedly and frequently in terrible ways. I would argue that that's not actually a bad trade-off, because if that's happening, you have larger problems. Like your boss probably calling you frequently and asking you why you're still employed. Or possibly you wondering why you're still employed, depending on how much responsibility you feel for this. Yeah. Someone is going to be very unhappy if that's happening frequently for your masters, I'd say. You've got bigger problems. So let me show you how you actually run this. So basically, there's two basic ways to configure. One is code. Don't worry too much about the specifics of the code. I know people get kind of wrapped up in trying to figure out what it's doing. Basically, the gist is there's a properties step you can set that sets the durability hint in this case. And declarative, it's an option, same behavior. You run it. First time it runs, it's not going to take effect. The next pipeline build will take it, though. It's just because of how properties work. Sorry, there's nothing I can really do about that. But once it's set for a flow, by the way, it's set. Your flow runs all the way in that mode. You don't get to change it on the fly. The UI you can also set up if you really like the Jenkins UI. I'll be honest, I don't. As a Jenkins core contributor, I think the UI is kind of ugly. Blue Ocean is much nicer, but yeah, I like to do code because I'm a programmer. I think that's true for most people. But if you want to do it the UI way, there's three levels you can set it at. Globally, you can set a default. For a pipeline, you can set it as an option at the top. You can also set it in multi-branch projects as a branch property. It's a little bit nitpicky. That's kind of in the branch configuration, the branch source configuration. But it's helpful for some cases where you might want to run deploys in your master branch and you want that to always have the maximum durability. But like PR tests, you really don't care. You're like, if this fails, we'll just run it again. Things to know. So each one of these is setting an override. Global is setting a default. If you set a per pipeline setting or a multi-branch setting, that'll override the global default. So you've got a lot of control over how you do that. And remember how I said it was the tip of the iceberg in terms of what you see? Yeah, this is what you see when you change the setting. You just get a little message in log. We're not going to make this super noisy. I don't want to set off like fireworks every time you run a pipeline. Just a nice little log message at the top to kind of tell you how you ran it, and that's what you get. But the bigger impact is actually performance. So this is kind of a complex metric to derive, but what I've done here is I've set up this fully Dockerized test environment, which I'm actually going to give a Jenkins World talk in France about next month, because it's actually quite proud of how this actually works. But basically, this is a set of different pipeline test cases running different sets of pipelines mimicking kind of important use cases in real-world scenarios in different concurrency levels, so there's a lot of jobs running at once. This is a 4-core master with 300 IOPS per second provisioned I/O in AWS. So simulating what you'd get if you had 100 gig GP2, sort of your standard storage volume after it's saturated the burstable I/O. Most people won't care about those details, but I know someone's going to ask. So this is percentage of your I/O capacity used while running. This is before, and this is after the changes when you set performance optimized. And this is actually kind of old. I've added some additional optimization, so the picture should be much better if I reran those benchmarks tomorrow. But you can see, for the most common cases here, your I/O use goes down to almost nothing. Even in some of the more intense scenarios, it drops considerably. Yeah, look at how big that difference is versus that. And the implication is that you'll get much faster performance, and you can run a lot more masters on consolidated hardware or use cheaper I/O solutions. The other part that I want to kind of touch on is reducing class loading, because this is sometimes a bottleneck, especially for complex pipelines. Before, after, you can see peaks drop a lot. In these cases where there's a lot of activity, it drops to almost nothing. Pipeline dynamically class loads with every pipeline you run because they're isolated, because they have separate classes, essentially. That's sort of how shared libraries are injected. So in this case, this means you'll get better performance out of your system as well. There's also, I should mention, threading implications for this. Class loading is, in many cases, going to be single-threaded because of how it interacts with the JVM. So this also means that you can run more concurrent pipelines. So don't bother trying to read all of this, by the way. This is just a long list of all of the other things that we did this year since the last Jenkins World to improve performance. The takeaway is there's been a lot of stuff happening behind the scenes. If you've been updating your plugins, a lot of this you probably already have. Kind of silently improving behind the scenes memory, runtime speed, CPU use reductions, I/O reductions, all kinds of different stuff that we've done in the last year to attack various problems. And there's a couple of other things I want to highlight that are coming up. So firstly, who here went to the talk, a cloud-native Jenkins? Can I get a show of hands? Okay, that's a pretty good fraction of this. So that's some of my colleagues at CloudBees, really great engineers. What they've done is set up a way to store your logs and artifacts and eventually other Jenkins things in cloud storage APIs rather than on disk, which helps tremendously with performance. There's also a re-architecture of how we do logging in Jenkins that will further help with storage performance. And a change in how we interact with shell, batch, and PowerShell steps, which are running on remote hosts, that has benefits for networking and should reduce execution times too. So these things aren't out quite yet. They're actually in my review queue right now or are merged and awaiting release just after Jenkins World. But they're coming up in the next couple of weeks, and those should help further. All right, so let me take a step back here. So I've just told you all the good stuff that's come out now and how you can use some of it and what's coming in the near future. This changes some of the guidance I've given in previous years and some of the best practices advice. I've updated Jenkins IO pipeline scaling docbook to reflect that to some extent. But basically, some of the optimizations I used to recommend, you don't need to do anymore. Your life just got easier. So for example, trying to reduce general step counts, don't worry too much about it anymore, as long as it's not shell or batch steps, because those carry extra overheads. I used to recommend against, and Jesse as well would emphasize this, recommend against storing large variables in your pipeline program. So one thing you'd see, like people would slurp in, say, a JSON object and do parsing and do some analysis on that in their pipeline. And that's something that's kind of handy to do, but when you persist that program state, all of the stuff in memory for pipeline is written to disk, so you can pick back up and resume your pipeline program. That's a problem if you've got 2 gigs of data stored in that pipeline's variables. If you use the performance optimized mode, you don't actually need to worry about that. That's not going to write unless you actually have to. Also, you don't really need to do as much I/O tuning or NFS config tuning. Just don't use spinning Rust. That's what the dinosaurs were probably using. It's slow. Just use Flash. It doesn't need to be super fast Flash, but use something that's solid state storage. And I already touched on kind of the logging changes that were coming. I'm going to touch on one specific topic that's near and dear to my heart, because I mentioned that there was a big Fortune 500 that was having major issues last week, which I can't name because they're a customer. So this is GC tuning. I get asked, do we need to still do GC tuning for Jenkins? Well, this is what happens if GC tuning kind of goes wrong. So along this axis, we have time. This is GC pause time. This is time when your master is doing absolutely nothing. It's not running pipelines. It's not responding to user requests. You'll get 503s from the UI if it takes too long. You'll get timeouts sometimes in different operations. Each one of these GC cycles here is triggering a pause time between 2 and 3.5 seconds. So that's long periods where masters are doing nothing. And in fact, one of the problems for this was half of the time the application was up, it was just doing garbage collection. Who here thinks that's good? Okay, cool. That's a very bad thing because it means your hardware is doing very little for you. So this is after applying the secret sauce settings that I've recommended a couple of years ago. So I've got a link here. If you Google Jenkins GC, you'll probably find the blog I wrote that explains how we got to these settings and gives you the specific ones. This is the exact same instance under the exact same workload. And it went from pauses of 3 seconds, 2 to 3 seconds, 2 to 3.5 seconds, down to about 50 milliseconds. So this is the 50 millisecond line. Oh, sorry, this is the 50 millisecond line. My apologies. I messed up my graph here. And a tiny fraction of a % of the time is spent doing garbage collection. So this is a master that's much more responsive. Things just run faster. They're making better use of their hardware. So people will ask, what do I need to tweak still? Honestly, 1 or 2 things. If you grab the settings from the link down there and just use those. We've been using them for a couple of years with almost no changes. They're running at much of the Fortune 500 right now, or some slight variant thereof. The one thing you need to set is maximum minimum heap sizes. I'm not going to go into a long discussion on that. Google it. There's very standard practices, not a big deal. Maybe 2. Small masters start with 2 gigs. Bigger masters that are doing more work start with maybe 4. If you need more than that, you could add a little bit more, but those are good starting points. The other thing you see less commonly is tweaking the region size. Now, I could give a whole talk on this. I won't, though. If you guys have questions about it, I'll be happy to explain after. But basically, the impact of this is that you'll see humongous allocations triggering garbage collection events in your GC logs. And that's a performance reduction for you. If you see a lot of that, you could increase the region size a bit to have that happen less often. They're multiples of 2 megabytes, or multiples of 2 all units in megabytes. The catch is if you make it too large, your efficiency of the GC will go down a little bit. So don't make it like 64 megs if you don't need to. Metaspace also, you can tune this a little bit so that it doesn't have to resize this in cycles after your master starts up. It helps a little bit with startup times. Okay, so that's kind of GC specifically. General performance advice, some of this I've touched on in previous years, much of it. I'll reference last year's talk I gave on scaling pipelines. Key things, takeaways, effective use of notifications reduces the human element of turnaround time for pipelines. Just don't spam the crap out of people because no one likes that, and people won't look at them anymore, so that kind of defeats the purpose. Timeout and retry steps are a great way to make your pipeline more robust against failures. It means you won't hang if like an API is down and you're waiting for, say, a response from that. Do still try to consolidate PowerShell batch and shell steps because those durable executions running on the build agents have some overheads, about a third of a second for each of them. So if you run a lot of them, it will slow things down a little bit. And don't use a pipeline as a one-size-fits-all tool. Sometimes it's better to let Maven or Ansible or pick your tool of choice, let that deal with some things that it's good at, right? Specialize a bit. Also, I'll mention this because I do still see a lot of people using NFS for sort of shared storage across different systems. NFS v4 is much slower than v3, and that's especially important for how it interacts with Jenkins. The performance optimized mode I showed earlier does make that better, but I would still recommend using NFS v3 if you can, especially if you're running a high-scale master. All right, so here's the really exciting part. We're going to completely change the way pipeline runs, completely. So who here knows what CPS is? Okay, who here likes CPS? Who here knows what CPS is and has had irritations with it? Okay, so basically everyone who knows what it is knows it's not fun. Okay, cool. So we're going to get rid of that entirely. We're going to put a stake through its heart. We're going to burn it. We're going to salt the earth where it was. And I'm super excited about this because I have to maintain this code. And there was a reason for it at the time, but it's proven to be just a giant pain in the butt. So what we're going to do is we're going to decouple from running all of your code on a monolithic master. So this is all your pipeline's execution itself is going to move off the master. Steps may still run there potentially, depending on if it needs master resources, but like all of that orchestration logic will be running outside of it, which means there's a lot of great things that you get from that. So for example, script security. Who here hates script security again? Awesome. You're going to be very happy. Script security is dying. We don't need it if that's isolated. That security boundary is provided by running in a separate system or container. Who here has found it frustrating to run a pipeline repeatedly to try to get the code right? Okay. Well, that's also going to change. We're going to be adding a debugger with this, which is possible because it's now running separately from the master. Also, who here has had a master come down due to something overloading in pipeline? Okay, that's less than I thought, and that's a good thing. That means I've done my work well. So that's also going to stop being a problem because what's going to happen is your pipeline will fail. That's okay. Your master will just be like, oops, pipeline failed. Well, maybe you should fix it. Won't bring down your master anymore. Also, this makes it, one thing I'm particularly excited about because I'm a performance nerd is it means it's going to scale out a lot better, which means you'll be able to reduce the memory and CPU use for your masters themselves. It means that you'll be able to take advantage of other systems to do that pipeline work elastically, so you don't have to have continuously provisioned resources. That's going to cut your IT budget for Jenkins. Also mention one of the other issues is finding that, okay, who here has had a team that has written a pipeline? You don't have to admit if it's yours, because but who here has seen a pipeline that runs that just like kicks the crap out of a master? It just slows things down, does a lot. Okay, so you've got one, there's a couple around, okay, yeah, okay. So one of the things that comes out of this is first, that doesn't hurt the master itself. It also means that you'll be able to figure out who's responsible and fix it. So that's going to help with administration. Also, there's one other feature I'm very excited to announce, which is going to be rainbows and unicorn farts, because I think we need more of those. So basically, that's where Pipeline's going. I'm going to be kind of vague because we're still working on a few of the details. I actually have a lot of the code already written along with one of my colleagues, but there's some things we're trying to incorporate still. But I'd love to hear afterwards if you guys have any thoughts about this, any things you want to ask about, or input and what would be important for you. I'm going to mention one aspect of this, though, that might concern a few people. And because I think this might be a little scary for some people, I'm going to give you something nice and relaxing with a kitten and a puppy. Also because kittens and puppies are awesome. So when you move outside of the master, that means you can't touch the master process directly. So what some people do is they'll have utility jobs that will kill other jobs, for example, to quiet down the master. They'll poke Jenkins internal APIs to gather information. They'll sometimes do sort of meta-programming within the master itself. Unfortunately, because that's now a separate process, you can't really do that if you change the pipeline execution engine this way. So that won't work. But I'll be honest, the places that I've seen that are usually what I would classify as clever hacks. Not very many people do it. Usually there's only a handful of cases. And if you are doing it, I'd love to know where and why so that we can make sure there's a good way to support that within this new execution engine. I'll take questions at the end for this part, because I'm almost to the end of the presentation. There will be some better ways to support this kind of feature set, so don't worry too much. But I want to put a couple more points here. Whenever I hear new engine or completely new way of doing things, I kind of have my sort of past operational mind going there, and that in the back of my head, I'm thinking, okay, what about compatibility? What about feature changes? So all the people involved with this work understand very deeply the importance of your CI/CD assets and code bases for your organizations. We know everyone has invested ridiculous amounts of man hours and different troubleshooting to getting these to do exactly what you want, the way you want to do it. And we're going to try to keep as much of that completely intact as we can. We're also going to do this as an incremental switch. So similarly to how I showed you the durability settings, you'll be able to configure when and where you use the new execution engine. So it's not a big bang change. You can migrate pipelines over one at a time, or switch over in bulk and then see if anything has issues. And hopefully there won't be any issues. But that's one way to kind of help with that. Okay, so I'm going to circle back in the systems theory. I had mentioned in my presentation abstract that I was going to talk about how to apply that to general DevOps. This is actually a diagram I used a couple of years ago, and I think it's still relevant. This is kind of decomposing your DevOps flow into different system interactions. So you've got your source control, your Jenkins master, build agents running ephemerally in the cloud or Kubernetes. You've got static build agents doing certain kinds of specialized workloads, notifications going to external systems, and other things I don't have in this diagram because it would make it too busy, but communicating to things like your artifact repo, AWS, Azure, GKE, APIs, whatever SaaS solutions you're using, these are all things that interact. So one way to kind of apply this same approach to your overall flow is to look at the inputs and outputs of each one of these systems and kind of map out how those are interacting. And then you can look for certain patterns that cause problems. So these are kind of common things you'll see across different kinds of systems. I showed you a couple examples within Pipeline itself. So for example, polling as a pattern is a performance problem because it means that you're constantly interrupting to check something. In general, you want to switch to push notifications, webhooks for HTTP stuff. This model is a little bit more robust. Only fall back to polling if you don't get a response, perhaps. Put a little timeout there, say, hey, I haven't heard anything from this API. Am I going to get a call back? Okay, well, let me poke it and see if it's even still running. One other one is middleman systems. Proxies are okay because they're kind of dumb load balancers. Similarly, service mesh implementations, usually you're just passing something through. But if you've got a system doing some intermediate processing, the question is, can I remove this middleman? Also, very tightly coupled systems that are constantly interacting. And this is actually something that's very common, and it's a little bit harder to solve. In general, think about parallelizing some of the work and letting them respond asynchronously so they're not so tightly coupled in a loop. Also, think about caching. Think about maybe, can these two systems be combined into one if they're constantly chatting? Can we at least move them physically closer so that the communication latency isn't as long? And finally, we'll talk about kind of the God system, which I actually would argue Jenkins in the current architecture is often a God system. It does everything. And that's good. That's a sign of how useful it is, but it's also a problem for system designs because you can't scale it. And that's something that I think everyone here probably saw, at least the first day's keynote, probably some of this one. Remember all the talk about Jenkins X and cloud native Jenkins? That's what we're trying to solve in Jenkins itself by splitting it up, removing some of the middlemen, using messaging systems to decouple. All of these things are great solutions for removing one central system that has too much power and too much responsibility. All right, so quick sum up. So basically we covered talking about system patterns. I ran through the project sheet of performance optimized durability setting and some of the other goodies. Explained where that came from and kind of gave some system examples within Pipeline. We talked about some specific optimizations you can do and some that you don't need to. I gave you a sneak peek about the new pipeline execution engine that's coming. Think of it the cloud-native pipeline execution, and sort of some general purpose theory for DevOps optimization. And it looks like I actually managed to wrap up just a little bit early. So thanks very much, guys. Thanks for having me. And let's have questions. You. Yes, so the question is, I teased about the pipeline debugger. When is it coming? Do you have it on the roadmap? It is included in the roadmap for new pipeline execution model stuff. I can't give you a specific date yet because that's a pretty large project. So it's coming along with some other goodies that it depends on. But it is in plan. It's coming. I hope to give next year's Jenkins talk about how all of my last couple of talks about performance no longer matter because we solved all of the problems. And also there was beer and ponies and all sorts of other wonderfulness. But it's coming soon. Okay. Gentleman in the blue shirt.
You mentioned that with decoupling the master from what's running on the script, we may not be able to have scripts that do things like kill other jobs. Would there be, an alternative way to
Yeah. So the question is, and I was actually waiting for someone to ask this one. So the question is, when you decouple the pipeline execution from what the master does, what do we do to do things like manage other jobs programmatically? And actually the answer is very simple. You can use the Jenkins API still, right? Because that's coupled by HTTP, so it doesn't matter where it's running. So you can use that to list or kill jobs. There's a CLI client for Jenkins that isn't used quite as much. There's also options to write plugins, and there should be some new kind of extension points coming with all of this as well. So there's plenty of options still.
It's not the Java native specific.
Right, exactly. Gentleman over here, I think you had a question earlier.
With regards to the decentralization of the pipeline.
Yes.
Is that only applicable to the pipeline engine, the ability, or are you going to allow the default region the ability to do a freestyle job in the same fashion?
So the question is, does this decentralization of the pipeline engine apply to other job types? I'm going to give a little bit of a nuanced answer there. So this specific work is just scoped to the pipeline engine. Consider this to be one slice of the pie that is the general cloud-native Jenkins effort and Jenkins Jolt. This is to some extent aligned with both of those. One of the open questions there is still the specifics of how to work with freestyle projects and other things. So those may support out-of-box external execution as just part of that new execution model for cloud native Jenkins. But I don't think that's been pinned down specifically yet.
Or is it possible that you just support, just offload everything to the pipeline engine, allow a freestyle format there? And will you also, will there be any level of granularity behind, like stages, for example? Could you just send a stage to an agent and not the whole job?
So, okay, so first part is if we could essentially migrate freestyle directly to pipelines for this purpose. I think that's actually more complex than it seems. There was a project that was shown off, I think it was last Jenkins World, that automatically does that conversion from freestyle to pipeline, and it turns out that while it's very clever in practice, it doesn't work a lot of the time. It's possible to do, it's a lot of effort. I guess I don't know that support for freestyle is going to be the highest priority. It may come along for the ride with cloud native, but I think that's, most people are sort of have moved away from that. And if it's something that's very important to you, I'd love to have a chat after and kind of hear a little bit more about what your use case is and why that's kind of important to you and how, basically how to best serve what you're talking about. There was a second part. I'm sorry, I've lost that. Oh, stages. Okay, question part two is, will there be a granularity within the pipeline to run just a stage at a time in external execution? And the answer to that is very simple, no. It's just too complex to support. It's just easier to offload the whole thing. And the way the internal APIs work would mean that we'd have to do breaking changes in pipeline itself to support that. Yeah. Yeah, you can still have different pipelines that are invoked from a parent pipeline triggered from it that are running in a more traditional execution mode. So, I mean, there's a lot of flexibility there.
To be clear, stages will still be able to run on separate agents in the new model.
Yeah.
It's just the pipeline itself will be isolated.
Yeah, so
it's not like you won't be able to run different steps on separate agents if that's what your pipeline is.
Yeah, so you'll still be able to use multiple agents in parallels. In fact, probably the use of parallels will be more efficient. One thing I'll mention, by the way, with those new performance and durability settings, those actually can make a really large difference to teams using large parallels on their masters. That's actually one of the kind of driving causes for this. Sorry, just something I wanted to mention in passing.
Makes it better or makes it worse?
Better, much better. Performance optimized, I guess I can go into sort of abstract specifics. Pipeline uses internally a green threads model. So pipeline's parallelism is implemented based on asynchronous steps that can launch something and then hand back the execution thread to something else, and that ties to persistence and sort of simplifying the overall execution engine for CPS. But that means that when you do those persistence, you're blocking that thread for a certain amount of time. So by unblocking it, that means that those parallel branches that can execute asynchronous operations like firing off different shell steps in different systems can run more efficiently because that overhead is reduced. That green threading overhead is less of a problem.
In what cases would you use a maximum durability setting in a parallel job? Given the properties that you can set, what cases would you actually use?
So the question is, when would you use a maximum durability setting? I actually have specific best practices guidance in the docs link to Jenkins.io and in the Cheetah blog announcement with a list of different cases. The TLDR for that is maximum survivability is if you're doing something absolutely critical or your master is known to go down frequently, possibly as a result of how you're interacting with cloud APIs. So if you're using a volume driver, if you're running Kubernetes and doing something with volumes that yanks the volume from the running master, rather than kind of doing a graceful shutdown and disconnect, then having that durability can be helpful. I think if I could break it down, I would expect that 99% of pipelines that run don't need the max survivability because you're mostly building PRs and branches and temporary stuff. Yeah.
Is there a reason, I guess, for people need to write in batches rather than the less durable, a bit faster setting? Like, for example, the master is not known to go down frequently.
Wait, so you're asking if, could you
Regarding the third setting, that's
Yeah.
not the optimize or the max durability. There was a second one that
Yeah.
avoids writes altogether. Would there be reasons to avoid that setting?
Okay, so the setting that keeps the durability, it still persists constantly, but it doesn't use atomic writes, the faster but still survivable setting. The cases where you wouldn't want to use that versus the max survivability are if you think something could fail at an operating system level, because basically what you get for that is operating system level caching of all of your write operations. So it can combine writes to do those more efficiently, and actually can have very large performance improvements for people. So that's the gain for it. The downside is if the operating system has the storage yanked from it, if you think someone walking through the data center might actually unplug the wrong hard drive while something is running, if you are disconnecting volumes from running instances without shutting them down, which is a thing that can happen in some particular Kubernetes settings, and can happen in AWS if something goes wrong with the volume potentially, the EBS volume.
To relate it a different way, the reason why you have a safely removed flash drive operation in your OS is so that it can persist all the cache writes to the flash drive before you pull it out. If you pull out just the flash drive randomly without that, the reason why you can lose data as a result of that is because the OS did not have time to lazily persist all of your saved Word docs to it. It's the same concept, just at an OS scale level with Jenkins.
Thank you, Sam. What Sam said. That's a much better metaphor.
So if we're not doing something critical, and if something like that gets corrupted, restarting is no problem, would you recommend a performance optimized setting in that case?
Yeah, in general. I think most of the time you should just default to performance optimized. The only reason I haven't changed the default is I wanted a little bit of time to have this marinate in the wild, and I wanted to keep the existing behavior. Honestly, I'm probably going to change the default for most masters in the future, pending kind of approval from other people. There's one more set of optimizations and fixes I want to get merged in first, though. Other questions? Did you have a question? Okay, I saw a hand up over there. Okay, I'm going to skip you for 1 second, Sam. Gentleman behind you. Yes.
Is it possible to have in the parallel step, can I have a sequence stages after starting in parallel?
Mm-hmm.
Can I have a sequence stages?
So you're asking if after starting in parallel you can have a sequential stages?
I need to have a parallel, something like that. In that one of the parallel, I need to have some sequence stages.
So you need to, basically what you're asking is, can I nest stages inside a parallel branch? The answer is yes. And both scripted and declarative. Declarative added that in the last 6 months. Scripted has had it since it launched. So yeah, and you can nest stages and stages and parallels and parallels and stages in parallels in stages in parallels, although I don't recommend it because it's really hard to work with. But you can do basically whatever your twisted mind can come up with. And scripted, yes. And there's more limitations in declarative. And I have test coverage for a lot of those kind of nesting scenarios as well, by the way. Sam.
So one thing you haven't touched on is shared pipeline libraries. I use those heavily. How do you envision shared pipeline libraries, which typically run in the master without sandboxing by default in this new detached pipeline model?
Great question, Sam. Yeah, this is the Sam and Sam thing we've got going on. It's been 2 Jenkins worlds like this now. 3, I guess, including this one. Yeah, so the question is basically how do shared pipeline libraries fit into this world with a new execution engine? Actually, it's very simple. They just work in that external execution. They're just another piece of Groovy that you include. So you still can't run on master APIs with a shared library, but they just work. It's just load another Groovy file into the shell. So it's actually somewhat simpler than CPS in many ways. Other questions?
You said something about PowerShell scripts not running for more than 0.2 seconds. What was that about?
Yeah, so those 3-step types that I described, shell, batch, and PowerShell are what are called durable tasks. There's actually a couple more options that are less known for that, but those are the ones most people use. those carry an overhead because essentially what you're launching is over the network on a build agent, you're launching this persistent process and something that captures, that wraps that and captures the log output and the standard out return, and you're periodically checking to see if that finishes. And so all of these kind of options, these things that you're doing carry a little bit of extra overhead, both because you're kind of constructing this more complex Baroque scenario to provide persistence across restarts, but also basically you're just doing more work. So they take a little bit more time than a step that's just doing like an echo or something. And those also trigger a couple of writes in the build agent too, because it's got to write a script file to run. It's got to set up those processes. It's got to capture the log output and the standard out capture the standard out output and the return status. I apologize. It was a late night last night. So basically, they carry overhead of about somewhere between a quarter and a third of a second generally.
It's not like you can't run the PowerShell script from one point.
No. You can run them as long as you like. In fact, that's pretty common to have very long ones. It's just that they carry sort of a minimal overhead, so you don't want to use them. You don't want to use them just to echo out one line of code or something like that. Use them for more complex operations, and they're great for that because you can offload all the work. Gentleman in the khaki shirt.
So with the new pipeline engine, you mentioned it continuously in the context of cloud native.
Yes.
What if we're not running in the cloud?
That's a great question. So I could do some architecture diagrams for you. Basically, the gist is that if you're not running in a cloud native context, you're still going to have a master providing some of the operations. So you'll have an external execution process that speaks back to the master, and the master will do things like running steps that are coming from a plugin that need a master. And so basically, you're replacing launching this CPS execution on the master with running a process somewhere else, and they're just going to communicate. Does that answer your question? Yeah. Okay. So it's someone has done some distributed systems work. I see. Yeah, near and dear to my heart. But yeah, the details are very important. Question here.
So off the answer you just gave, I guess, where would it run? Like in the non-cloud, the external?
Right. Probably. Hey, Andrew, you think I can drop this one out?
I wasn't listening.
Okay. All right. Well, some of this is still being discussed internally, but I think the current plan is that it would use an executor slot and a build agent to launch it. But that's a convenience for creating it. It doesn't really need to keep a continuous connection like you would for a normal executor. So it's just basically using that as a resource management tool and a launch mechanism. So basically it integrates natively with your existing Jenkins installs. It should be very seamless. Other questions?
On this new pipeline format that's going to, can you use Jenkins Git instance for Git queues or Git nodes for manipulating queues or agents?
No, all of those are on master APIs. So if you're going to do that, you need to either use invoking the REST APIs in the master or the CLI, or write a plugin that does it, or there may be some additional extension points for stuff that needs a master, which I'm going to be a little bit hazy about because there's a couple of different implementation strategies for that right now. But I mean, there will be a path for it. It just won't be running a custom management script in your pipeline. All right, who else has questions? Gentleman in the gray shirt.
In the Kubernetes world, when you're talking about moving the execution off the master, is that so I bring up my pod and I have, say, a JNLP container, and then the execution of the actual pipeline and stuff would happen inside the JNLP container, and then just send the commands to all of the other containers in my pod to run the steps?
So I'm going to defer in that question until I have the implementation done for that particular aspect of the system. There's a couple of different proposals circling around. My preference would be to integrate more natively with Kubernetes APIs in general, because I think that's a better path forward and to make a better use of a microservices model. But I don't want to give you an answer and then have something change in the architecture because we find a more clever solution for parts of this. Other questions? Time? Oh, okay. I better disconnect then. All right. I'll be available in the community booth if you guys have any other questions that kind of come up after this. Thank you very much, and enjoy Jenkins World.